We are trying to find the area of that triangle right there. And we know that this line is parallel to this line. So, see how I have a triangle here? And then there's also one here. And if I can show that the big triangle and little triangle, if they share two angles, or if they have two equal angles, then they're similar. Well, they definitely share this angle. That's the little one and the big one share that one. So there has to be equal angles. And if I was to extend this line here and extend this line, they're called vertical. I think they're called vertical or corresponding. They're called corresponding angles. This one of the little one is going to have the same measure as that one of the big one. Okay? So now I've shown that I have similar triangles. So what I can do, all I need to do is find x. If I find x, I can find the area of that triangle right there. So what I'm going to do is set up similar triangles. So look at AC. AC is this one over here. That's the big. AC is to BC. That's the little one, corresponding side, BC. Let's do the same thing. Let's find another corresponding side where we involve the X. Now, AC is the big triangle, so I need to have the big triangle on top. So the big triangle would be, look on this side, I'm going to go back to black, would be this. CE, I know it looks awful, but it's not too bad. That's the big one, that's a corresponding side to CF. This side here to this little one, okay? Well, what is AC? The measure of AC is 30 plus 30, which is 60. And BC is labeled as 30. It was all given. Look at CE. CE is going to be, I didn't label this, but it's actually 15. So CE is going to be X plus 15. And CF, where is CF, is X. So let's solve this. And we have a fraction equal fraction, so we can do cross multiplication. So that's going to be 60x equals 30 times x plus 15. And that's 60x equal 30x plus 450. And that's going to be 30x equal 450. And then divide both sides by 30, that's going to be 15. So this equals 15. So let's pull that triangle out by itself. So we know this side is 30. We know this side is 30. We know the base is 30. If I drop a perpendicular line, that means I've got 15 here and 15 here, and we're trying to find this height, okay? You could use Pythagorean theorem, but you're going to have a squared plus b squared equals c squared, so your numbers are going to get kind of big. We know that since this triangle, all three sides were 30, that means all the angles had to be equal. And the sum of the angles of a triangle are 180, so that means that each angle would be 60 degrees. So if this is 60, and then of course this one's 90, they change colors. This is 60, that means this is 30. And a 30, 60, 90 triangle, you just have to memorize this. If this is the right angle and this is the 30, the relationship is the opposite would be 1, the hypotenuse would be 2, and the other leg of the triangle would be square root 3. So just know that the opposite side of the 30 is always going to be a 1. The hypotenuse will be a 2, and that other side will be a 3. So we can do similar triangles again. I'm trying to find this, because this is the height. So I could say 1 is the square root of 3. 1 is the square root of 3 as 15 is to h. 1 is the square root 3. That's my proportion of my relationship of my angles. And then I pull those same sides from the triangle I'm working on. Solve this for h. H equal 15 square root 3. We know the area of a triangle is 1/2 base times the height. So the area is 1/2 times the base. The base of this big triangle is 30. And the height is 15 square roots of 3. So 2 will go into 30, 15. 15 times 15 is 225 square root 3. So that's one of your answers. That's it.